All right, so we're talking about graphing polynomials. Yesterday we talked about like adding and subtracting and multiplying polynomials. Today we're going to talk about graphing. So really we're going to graph stuff that looks like this. Isn't that fun? Yeah. Yep. So there's some things that you need to know in order to graph something like that. The first thing is what we call end behavior. All right, you don't have to write all this down if you don't want to. It's going to get posted, and it's also on a video. So, hi, video watchers. Hi. I know they can't see this, but so end behavior, what is it? It is what happens as a graph goes to positive and negative infinity. So pretend you have a graph. Let's say it's a well, I don't know. Let's say it's weird. Let's say it looks like this, something goofy. So the end behavior is asking, what is the graph doing as you move this way forever and ever and ever and ever and ever? What's the graph doing? It's also asking what's it doing as you move this way forever and ever and ever. Yep, on the x-axis. Just asking what is the graph doing infinitely to the right and infinitely to the left. That's what end behavior is. And I'll show you how we write it in a second. Two things that we need in order to determine end behavior. The leading coefficient will tell you what the right side of the graph does. That'll tell you what the right end behavior is. Specifically, whether or not it's positive or negative. The leading coefficient is positive, that means something. If it's negative, that means something. I'll tell you all this in a second. The other thing that we need for end behavior is the degree. You guys remember what degree is? What is it? It's the biggest exponent that you see. So like this right here is a third degree. And I'll show you what all this means in a minute. Odd degree means the sides don't match. Even degree means the sides do match. So in order to determine the end behavior of the graph, these are the two things you need. You need the leading coefficient and you need the degree. And I'm going to do an example of this in like 5 seconds. Bless you. Okay, can I do an example of this? Okay. All right. So let's zoom in a little bit. Let's just do this first one. It says, for the graphs below, plot the zeros first, plot the y-intercept, and then approximate the rest of the graph. So what we're doing is I want to take this thing, and I want to graph it. All right? We're going to piece this together using a couple different things. Okay? So bear with me as we get through this first example. It might seem kind of weird. But I promise it won't be. Did I unplug this with my foot? I don't know. You can plug back in if you need to. All right, end behavior. So to find the end behavior, remember you need two things. You need the sign of the leading coefficient, and you need the degree. So to find the sign of the leading coefficient, basically all you need to ask yourself is there a negative sign in front of this thing? Is there a negative sign in front of that thing? No. No. There's not a negative sign in front. That means the leading coefficient is positive. All right? So remember, that tells you what the right side does. The leading coefficient is positive, so that means that the right side of the graph goes up. If it was negative, that means it goes down. Okay? So since it's positive, I can say that the right end behavior is going up. And that's how we're going to write end behavior. Like is it going up and up? Is it going down and down? Is it down and up, or vice versa, right? Since the leading coefficient is positive, that tells me the right side is going up. All right. To get the left side, I need to think about the degree. So I know I told you the degree is the biggest power that you see. This polynomial, though, is not like this polynomial. It's different. What's different about it? Yeah, it's kind of written like how we started. You know what I mean? This is what we would call its factored form. Because it's factored. It's written as all these things multiplied together. You do not, in order to do this, you do not need to multiply it out. In fact, if you multiply it out, it's going to make things a lot harder. The factored form is going to be the easiest way to look at it, okay? To find the degree in factored form, all you have to do is count how many x's you see. How many are there? 3. So it's a third degree. Because notice how this one had 3 x's to start, and after we multiplied it out, oh my gosh, what degree was it? 3. So the number of x's that you start with is going to be the degree of the polynomial. All right. Okay, so here's where things get a little funky. We're trying to find the left side of the end behavior. Degree is going to help us do that. So let's just go back for a minute. The degree tells you if the sides match. If it's odd, that means the sides don't match. And if it's even, that means the sides do match. Is this odd or even? That's odd. That means the sides do not match. Okay? So if this one's going up, what does this one need to do? It means it needs to go down. So there's our end behavior. The left side is going down and the right side is going up. Okay? Let me tell you about the way I remember this end behavior thingy and the degrees. All right? We've talked about football a little bit. Who watches football? You don't have to watch football to get this. It's okay. So in a football game, if a team scores a touchdown, what does the ref do? They do this. If it's a touchdown, like, oh, touchdown. Okay. So, well, this is even. When it's a touchdown? Oh, like, oh, you're saying if the other team, like the other team's like, oh, no. Oh. Oh, I gotcha. I gotcha. Well, either way, this means touchdown. Think about the ref. If the ref knows what they're doing, if they're a good ref, like they're not some scrub they just picked up off the street, they know what they're doing. Yeah, the street. They will see the touchdown and they'll say touchdown because they know what they're doing, okay? Let's say the ref does not know what they're doing. They suck. Bad ref, or they paid off. Yep. Let's say the ref is bad. Maybe we could think of the ref as being odd. Oh. If it's an odd ref, they don't know how to signal touchdown. So they might cross the goal line and the ref blows his whistle. Touchdown. This is not what it is. You see what I'm saying? Yes. What? That's the joke. The odd ref doesn't know how to signal touchdown. Oh, yeah. That's the, well, but yeah, that's the joke. I'll show it later. Remind me. Does this ref thing make a little bit of sense? Okay. I'm going to finish this one out, and then we'll talk about the ref thing one more time. Zeros. What are zeros again? It's a fancy word for something. It's a fancy word for the x-intercepts. Fancy word for the solutions, the x-intercepts, okay? To find the zeros, all we need to do, it's like you were solving this, right? If you were solving this by factoring, what would you do? You'd set all these things equal to 0, right? And you'd solve them. That would give you your x-intercepts. They're all pretty easy to solve. All you need to do is flip the signs. So the zeros are -1, 1, and 2. You okay with how I got those numbers? So those are the x-intercepts. I know this is a ton of pieces right now, and you're probably thinking, what the heck? Why are, like, when is all this going to come together? It's going to come together in a second, all right? Yep. So, like, if you were going to solve this, you would set each of these equal to 0, and you'd get those numbers, okay? Y-intercept. Here's how you get the y-intercept. I got to write my equation down here. +1, -1, -2. Any ideas about how we get the y-intercept? What do you think? Make x 0. To find the y-intercept, just make x equals 0 in your equation, and then we're going to figure out what this number ends up being, okay? We got to do parentheses first. So 0 + 1, that's 1. 0 - 1 is -1. And 0 - 2 is -2. And what am I doing with all these numbers? I'm multiplying them. So I figured out what they are. Now I just got to multiply them. 1 times -1 is -1. -1 times -2 is 2. So that's the y-intercept. You okay with that? So the y-intercept is +2. All right, so I have all the pieces now. I got everything I need to put this graph on the grid. Here's how I'm going to do it. First, I'm going to go plot each of my zeros. So I'm going to get a dot at each x-intercept. So -1, 1, and 2. Let's also get a dot at the y-intercept. So we're on the y-axis now. So I got to go up to 2. There's that. Okay. You guys okay with why those are where they are? All right. Here's where the end behavior comes in. Remember, end behavior says if I go this way forever, the graph's going to go up. So once I cross this point, it has to go up. I don't know exactly what it's going to look like. I just know it's going to go up. You okay with that? So what's the left side doing? I don't know exactly what it looks like, but once I cross this point, I'm going down. Yeah, so you can kind of see what it's going to look like, right? At this point, all we got to do is connect the dots. So let's say I'm moving left to right. The graph is doing this, so from here, I need to go up there. Go get the y-intercept, okay? Where would I need to go from there? Down to what? Down to the next x-intercept, yeah? All right, so here's the deal. From here, I got to get over to there. So it's going to cross. I don't know how far down it goes, and I don't really care. All I care about is just a general idea of what it looks like. Once you get into some later math classes, you'll care more about how far it goes down. But for us, it doesn't really matter. I just want a general idea of what it looks like. So it doesn't really matter how far it goes down. And there it is. That's my graph. Whoa. You're welcome. I don't know who said that. All right, I'm going to get you started on this one, and then you're going to try some. Yeah. So it was all based on the leading coefficient and the degree. Okay, so let's do one more with the end behavior, and then you guys can finish this one on your own. End behavior. This is how we determine if it's up, down, whatever. You need two things. You need the leading coefficient, and you need the degree. What's the leading coefficient? Is it positive or negative? It's positive, just because there's no negative, right? Don't overthink it. It's positive. The degree, again, is how many x's there are. How many x's are there? 1, 2, 3. This one looks a little bit different because it's not in a parenthesis, but that's okay. It's still an x, right? So there's 3. It's a degree 3, all right? What does the leading coefficient tell you? Leading coefficient tells you what the right side is doing. It's positive, so what does that mean? The right side's going up. To find the left side, we got to think about the degree, and this is where the football ref comes in. The degree is odd. Odd football ref does not know how to signal touchdown. The sides don't match, right? Yeah, like if this was 2, then it'd be this. Does this make sense? So what is the left side doing? Up or down? It's going down because it's odd. Does this make a little bit of sense? Okay. The zeros. Again, you just got to switch these. So one of them is 2, one of them is, or sorry, one of them is -2, one of them is 1. What do you think this is going to give you? Just 0, right? A single x just gives you 0, because if you set it equal to 0, it's just x equals 0, right? So those are the zeros. Do you think you can finish this one? Yeah. You need to find the y-intercept, so that involves plugging in 0 for everything. What's going to happen if you plug in 0 for this? Everything becomes 0, right? Because it's 0 times 0 plus 2 times 0 minus 1, but you're multiplying it all by 0. So everything's just 0 on the y-intercept. Okay, turns out I'm finishing this one for you, and then you'll do one. X-intercepts are -2, 1, and 0. The y-intercept is also 0. That's okay. That's fine. Bless you. No big deal. You okay with those dots? All right, you tell me, what's up with the end behavior? What do I need to do? Down and up. So here, I'm down. Here, I'm up. So now I just got to connect the dots. I'm going up. I got to come down and hit that. I cross it, and I come back up to that. And again, I don't really care like how high you go or how low you go. It doesn't really matter. I just want a general idea. Yeah. Like here? That's just because the y-intercept is 0. Yeah. You just have to hit every dot. So like on this one, the y-intercept was up here. So that's why we had to go up and get it. Yes, yes. This one just happens to be 0, but it won't always be like that. Are you guys okay with this? Okay, why don't you try this one on your own? It'll be a little bit different. Ready, set, go. All right. I'm going to do this one. Some of you got it. Some of you are working on it. Let's just get on the same page. So to find the end behavior, I need the leading coefficient and I need the degree. Is the leading coefficient positive or negative? It's positive because there's no negative. What does that mean? What's going up? The right side. So the leading coefficient is positive. That means the right side's going up. The degree. What's the degree? Because there's 1, 2, 3, 4 x's. That is even. That's an even number. Even football ref. Means the sides match. Yes? So, what's the left side doing? It's also going up. The zeros, you just got to switch these numbers. So it's -3, -1, 1, and 2. The y-intercept means you plug in 0 for all the x's. So that's 0 plus 3 times 0 plus 1 times 0 minus 1 times 0 minus 2. Yeah? That is 3 times 1 times -1 times -2. What is that? Are you raising your hand, Hazel? Oh, okay, of course. Of course. What is that? 6, positive 6. So that's the y-intercept. I got all my pieces, so now I just need to put them on the graph. Zeros are -3, -1, 1, and 2. Y-intercept is 6. Up, up. So from here I go up. Okay with this? Then you just connect the dots. We're coming down, we cross, we come up, we get that. We got to go get the y-intercept. Come down. Oh, that was bad. Jeez. Yeah. Remember, it doesn't matter how far you go down as long as you just get a general sketch. Okay?